Hello everyone, I am Sandhya Kamar, Assistant Professor Chhattisgarh Swami Vivekanand Technical University Bhilai. In previous lecture, we covered the methods of plane table survey. There are 4 methods. In that, we already covered 3 methods. In today's lecture, we will cover the last method, which is resection method, and include some method of the resection. The process of determining the location of the station occupied by the plane table by means of drawing rays from a station whose location have already been plotted on the sheet is called resection. Means that resection is a surveying method where the position of the plane table is determined by drawing lines or ray from already known points on the map. This method, which is also generally known as interpolation method or fixing method, consisting of drawing rays from known point whose location are already available on the sheet. The intersection of these rays will be at a point if the orientation of the table was correct before rays are drawn. It is seldom possible to get an accurate orientation even with a magnetic compass. Means that it is only sometimes possible to get an exact orientation even if we have a compass. The problem therefore lies in the orienting the table at the unknown occupied station. It may be solved by one of the following methods. First one, back ray method. Second one is 3-point method. Third, 2-point method. Fourth, a box compass method. In back ray method, in this method, the plane table is oriented by laying the LED along the line drawn from the previous station. The location of the unknown occupied station is determined by drawing a ray from another station or point whose location is already plotted on the sheet, ensuring that two rays intersect at a good angle. Means that in this surveying method, the plane table is aligned with a previously drawn line and the location of the unknown station is found by drawing a line from the another known point on the map, making sure that the two lines intersect at a clear angle. Let's go to the procedure. The following steps are followed. Let A and B be two ground stations whose location small a and b are plotted on the sheet. You can see at the given figure. Set up level and center the table over the point capital B, placing the LED along small b and A. Rotate the table till the station capital A is sighted and clamped it. Pivoting the LED about small b, sight the station capital C and draw a ray small bc. Draw ray also at the extremities of the LED edge. Shift the instrument and set it up at point C. Center and level it over the ground point. Next, place the LED along small cb and rotate the table till the station capital B is sighted, ensuring that the line small bc remains vertically above the ground point C, capital C. With the LED pivoted at A, sight the station A and draw a ray to intersect the ray previously drawn from station B for C. It gives the required location of the station C, which is capital C, which is what we called as instrument station. Suitability of this method. It is available in the center of the area, means that this method is useful in plane table surveying when there is a noticeable landmark like temple, spire or chimney located at the center of the survey area. After setting the plane table at succeeding station, their location can be obtained by drawing rays from it. This method is also suitable for large scale survey where long rays are possible. The accuracy of this survey depends upon the accuracy with which the initial setting of the table was made. Precaution: In orientation the table by Baker method, the following precaution must be taken. The actual plotted location of the station on the sheet, not the center of the table, must be centered over the ground station mark. An error of 30 cm in centering, and in the case of short ray of 20 meter introduce an error of 1 degree in orientation. This error is accumulative. The forward station must be carefully selected and marked by the wooden peg before a forward ray is drawn. The back station must also be similarly marked with a wooden peg by transferring its position vertically below the plotted position with a U fork before leaving the station. The forward ray should be marked on both the edges of the LEDate so that an accurate setting of the table can be made by using the full length of the LEDate at the next station. The same side of the LEDate should be used for drawing rays. So we done with the back ray method. Next, 3-point method dissection. Finding the location of the station occupied by plane table on sheet by means of sighting 2-3 well defined points whose location have previously been plotted on the sheet. It is known as a 3-point dissection. In this method, the plane table is set up with the help of 3 known points without visiting them. Let small a, b, c represent the location of capital A, B, C, 3 ground station, and P represent the instrument position, the location of which is to be determined. The table is said to be oriented when rays drawn from the 3 points capital A, B and C intersect at a point and they do not form any triangle. The point of intersection of 3 rays is required location of the instrument station capital P. The orientation of the plane table by 3-point method can be achieved by one of the following method. First one, mechanical. It is also called as tracing paper method. Second, graphical method. Third, trial and error method, which is also called as Lehman's method. First method is mechanical method or tracing paper method. Let A, B and C be the 3 known points whose location on the sheet are respectively small a, b and c. The instrument station P is represented on map is small p. Let's go to the procedure. Following steps are followed. Set up the plane table on the station P. Orient it roughly with the help of magnetic compass or by eye judgment. Second, fix a tracing paper large enough to include the location of all the 4 points on the sheet. Mark a point P dash on the tracing paper to represent the instrument position. Third, pivoting the LEDate about P dash and sight capital A, B, C in turn and draw a ray P dash capital E, comma P dash capital B and comma P dash C on the tracing paper. Now remove the tracing paper, move it on the sheet in such a way that the lines P dash A, P dash B and P dash C are made to pass through the plotted location small a, b, c of the ground station respectively, means that exactly lies on already plotted point on the ground. Pick through the point P dash to get location small p of station capital P on the sheet, means that with the help of small p dash on the tracing paper locate the ground station point on the sheet. Align the LEDate along the longest ray small p a. For example, assuming capital A to be the farthest point, rotate the table until the point A is sighted. Pivoting the LEDate about the location small b and c, draw a rays from station capital B and C. This ray should also be passed through the point small p. This provide This provides a check on the orientation of the table. It may be noted that accuracy of the works depend upon the accuracy with which lines are drawn from the assumed position of the instrument station on the tracing paper, and also upon the fineness of the line drawn. This method may be used only to survey details point. It should not be used for providing control points. Second, graphical method. There are various methods for solving 3-point problem graphically. Only important ones have been described in this lecture. In this method, with the help of 3 ground station point, with the help of that, find the instrument station. First one is Bessel method, second is method of arc, third is perpendicular method. Let's discuss first one, Bessel's method. Let capital A, B and C be the ground station whose location on the sheet are represented by small a, b and c respectively. Let small p represent the instrument station of capital P. Let's go to the procedure. First, set up the instrument on the station capital P, align the LED along B to A and rotate the table till station capital A is sighted and clamp the table, pivoting the LED about small b and sight the third station capital C and draw a ray by small bc. You can see it into the given figure 1. Align the LED along A to B and rotate the table till station capital B is sighted and clamp the table, pivoting the LED about small a, sight the third station capital C and draw a ray to intersect the ray small bc at D. You can see it into the given figure 2. Join the DC, keeping the LED along DC, rotate the table till station C is sighted. Clamp the table which is now correctly oriented, pivoting the LED about A and B, sight capital A and capital B station in turn and draw a ray to intersect on the line DC. If the work is accurate, you can see it into the given figure 3. This method is sometimes called as Bessel's method of describe quadrilateral as the points small a, b, c and p lie on the circle passing through them. If the instrument station B lies on the circumference of the circle passing through capital A, B, C, Bessel method is not suitable. Next is perpendicular method. In perpendicular method, let's capital A, B be the ground station and small a, b, c be their location on the sheet. The location of the instrument station may be obtained by sighting two given 3 points or station points. Let's go to the procedure. Draw a line small ad perpendicular to the small ba at A. You can see it into the given figure. Align the LED along DA and rotate the table till station A is sighted and clamp the table, pivoting the LED about small b and sight capital B station and draw a ray through B to intersect small ad at small d. Draw a line small cm perpendicular to the small bc at point small c. Align the LED along small mc and rotate the table till station capital C is sighted and clamp the table, pivoting the LED about small b and sight capital B station. Draw a ray through small b to intersect small cm at small m. Join the dm small dm and drop a perpendicular small bn from small bm on the dm and is the required location of the instrument station. Align the LED along small na, assume A to be the farthest station and rotate the table till capital A station is sighted. Draw a rays from other station capital B and C which will pass through small n if the orientation is accurate. In short, to determine the location of the station using a plane table, first draw a perpendicular line from point small a to small ba at the line of small ad. Align the LED along small da and rotate the table to site station capital A and clamp it. Then pivot the LED at small b and site a station capital B and draw a ray intersecting small ad at point small d. Next, draw another perpendicular line from which point C to small point BC. Align the LED along small mc, rotate the table to side the station capital C and clamp it. Pivot again it at point small b and side station capital B and draw a ray intersecting small cm at a point small m. Join the point small d at small m, then drop a perpendicular line from the point small b to small dm to find point small n, which represent the station location. Finally, align the LED along small n a. Site the station capital A and verify the orientation by drawing ray from station capital B and C to ensure they pass through the point small n. Third method is method of arc. The 3-point problem may also be solved by the method of arc as described below. Let's A, B and C be the ground station whose location on the sheet are A and B and C respectively. Let's capital B be the plane table position whose location small p is desired. Let's go to the procedure. The following steps are followed. Set up the plane table at capital P and level it carefully by the eye judgment, or orient the plane table in such a way that location of point towards their respective ground location ABC. Join small ABC to form a triangle ABC. Pivoting the LED about A, B and C, in turn site respective ground station capital A, B, C and draw a rays. Locate the points of intersection of the rays from A and B as small ab, from capital B and C as small bc and from A and C as small ac. Draw a circle to pass through A and B and AB. Draw another circle to pass B and C and BC. Similarly, draw a circle to pass through A and C and AC. The point small p at which this circle intersect, it is the required location of the plane table station. Align the LED along small pa, assuming A to be the farthest station, and rotate the table to side the ground station capital A. Draw a rays from the ground station capital B and C. This rays shall be passed through small p if the orientation is correct. We have already seen that the 3-point problem lies in orienting the table at the point occupied by the table. In this method, the orientation is done by trial and error, and it is therefore also known as trial and error method. Let's discuss with trial and error method. In this method, the location of the station occupied is determined by trial and error. This method was invented by a well-known mathematician Lehmann, and hence this method is sometimes known as Lehmann's method. After orientation by eye judgment or with the help of magnetic compass, the rays are drawn to capital A, B, C, pivoting the LED about small ABC. If the orientation is correct, the ray will intersect at one point, which gives the required location of the instrument position. This seldom possible to get an intersection of 3 rays at a point. Generally, 3 rays intersect, forming a small triangle known as a triangle of error. The size of the triangle of error depends upon the angular error in the orientation. There are 3 cases which are to be considered while solving the triangle of error graphically. Cancel the last line. There are three cases which are oriented. Means that after orienting the table by eye or compass rays drawn to the points capital A, B and C, if the orientation correctly, this ray should be intersect at a single point indicating the instrument position. However, they usually form a small triangle called the triangle of error caused by slight orientation error. The size of the triangle depends on the angular error. Procedure of trial and error method. Set the table at B and orient the table approximately so that AB parallel to capital AB and clamp the table. Keep the LED pivoted about small a and side station capital A. Draw the ray. Similarly, draw rays from small b and C towards the capital B and C respectively. If the orientation is correct, the three rays will meet at one point. If they will meet in 3 points forming a one small triangle of error. The triangle of error so formed will give the idea for the further orientation. The orientation will be correct only when the triangle of error is reduced to point. To do this, choose the point P dash. The approximate choice of the position may be done with the help of Lehmann's rule described later. Keep the LED along P dash A and rotate the table to side station capital A. Clamp the table. This will give the next approximate orientation but more accurate than the previous one. Keep the LED at small b to side the station capital B and draw the ray. Similarly, keep LED at small a and side capital C. Draw the ray. This ray will again meet one triangle, the size of which will be smaller than the previous triangle of error. If P dash has been chosen judicially, keeping in view the Lehmann's rule, thus by successive trial and error, the triangle of error can be reduced to a point. There is the two technical terms in trial and error method, great triangle and great circle. The triangle formed by joining the ground points capital A, B, C on their location, small a, b, c on the sheet is known as a great triangle, which is given in the figure. And great circle, the circle passing through the ground points A, B, C, capital A, B, C on their location, small a, b, c on the sheet is known as a great circle, which is given in the figure. In Lehmann's rule, Mr. Lehmann, a well-known mathematician, suggested the following rules for solving the 3-point problem. First rule, rule number 1, if the instrument position capital P lies inside the great triangle ABC, the triangle of error will also fall inside the great triangle and the point P dash should always be chosen inside the triangle of error. Similarly, if the instrument position P lies outside the great triangle capital ABC and the triangle of error will also fall outside the great triangle and the point small p dash should be chosen outside of the triangle of error. Rule number 2, the point P dash should be chosen such that its distance from the rays capital A small a comma capital B small b and capital C small c are proportional to the distances of P from capital A, B and C respectively. Rule number 3, in case the triangle of error falls outside the great triangle, point P dash should be so chosen that it is on the same side of the ray small a, capital B, small b, capital C, small c. That is, if the point small p dash is chosen on the right side of capital A and A, then it should be also be on the right side of the other two rays. Rule number 4, when the point P lies outside the great circle, the point P is chosen on the same side of the ray drawn to the most distant point as the intersection of the other two rays. Rule number 5. When the point P lies outside the great triangle capital ABC but inside the great circle, that is within one of the three segments of the great circle formed by the sides of the great triangle, the ray drawn towards the middle point lies between the point small p dash repeat and the intersection of the other two rays. The third method is 2-point problem. In 2-point problem, finding the location of the station occupied by the table on the sheet by means of citing two well defined points whose location have previously been plotted on the sheet is known as 2-point problem. Let there be the 2 points A and B whose location have been plotted as small a and b on the sheet. Let capital C be the instrument position whose location is required. Let's go to the procedure. Choose an auxiliary point capital D such that capital CD is approximately parallel and roughly equal to capital AB station by the eye judgment. Second, orient the table over the point capital C such that location small a and b lie parallel to their ground position capital A and B. This can be done by eye judgment and clamp the table. Pivoting the alidate about small a and b, draw a ray to intersect at small c. The degree of accuracy of the location C thus obtained depends upon the approximation that has been made in the orientation. Transfer the point C on the ground with a U fork and fix a wooden peg. Pivoting the alidate about C, sight the station capital D and draw a ray. Also draw a rays at the extremes of the alidate. Shift the table to the station D and orient it accurately with the back ray method, ensuring that the ray small cd passes through a point vertically above the ground mark point capital D. Pivoting the alidate about small a and b, draw a resector which will intersect on the line drawn from capital C if the orientation was correct. If not, pivoting the alidate about the point of intersection of the rays drawn from station point capital C and obtained from capital A, sight the station capital B. Draw a ray to cut small cb at B dash. Align the alidate along small AB and rotate the table until the point capital E is again sighted and clamp the table. Pivoting the alidate about A and B, draw a resector to intersect at capital D. Pivoting the alidate about small d and draw a ray towards station point capital C. Shift the table to capital C station. Orient it with a back ray method. Pivoting the alidate about small a and b, draw a rays. The ray intersect on the line draw from capital D to give the correct location of the instrument station capital C. Suitability of this method. The accuracy of interpolation by 2-point problem depend upon the selection of the station point capital D, which should lie on the line approximately parallel to station point capital AB. Station point CD should also be equal to distance as station point capital AB. The dissection by 2-point problem does not give much reliable result. Moreover, labor and time was wasted to set the table at 2 stations to achieve the orientation. Last method is a compass method. Orientation by compass procedure are followed. Let's go to the procedure. Select a baseline AB as in the case of orientation method. Measure it accurately and plot a point small a and b on the sheet in a convenient position. Set up the table at station point capital A and center the location small a over the ground mark point capital A. Level the table. Place the LED along small AB. Orient the table by turning it until the station capital B is sighted. Clamp the table. Place the magnetic compass on the table and rotate the compass till the magnetic needle rests north-south direction. Draw a line along the longer side of the compass. Shift the table to the next instrument station C and level it. Place the compass in its marked position and rotate the table till the magnetic needle rests in north-south direction and clamp the table. Pivoting the LED about the points small a and b, draw a resector to intersect at a small c point, which is the required instrument position. Suitability of compass method. This method is suitable only in areas which are not magnetically disturbed and when the scale of the survey is comparatively small. The magnetic compass should be in perfect working order to achieve accurate result. You can see in the given figure for the example. Thank you.